Hello and welcome to my talk on exploring functional options in Python. I was first inspired to talk about this coming from Golang because I saw this pattern there and I don't remember seeing it anywhere in Python. And by exploring implementing it in Python, I noticed that there were some advantages but also some disadvantages. But that led to me finding even better alternatives. The solution is a bit awkward, but it is worth exploring because it does lead us to understanding better why certain things work better than others. Who am I? I'm Rami. I'm a senior backend engineer based in Amsterdam, and I like building stuff on the side, my latest project being Dataline. You can also find me on Twitter. I talk about all things development, also sharing progress on my side projects. First, we're going to start with a story. There was an engineer named Sam who sat down for a project kickoff. He was tasked with creating a client for interacting with document analysis service. It supported all kinds of documents and also supported OCR, which is optical character recognition. This is what's used to extract text from things like receipts, for example. And Sam is told that for the project itself, there's no need to support OCR. We just need to support basic documents like text files and emails. And that's all that's needed. So he begins his work starting with a simple client interface that interfaces with the service, does all that's needed. And this is his first iteration. Going over the code, we see a function called getText takes a file as an input and two other arguments. There's also a docstring, which is nice, and it works perfectly. Sam submits his code, people start using his client. Everyone's happy. But then all of a sudden, Sam's boss comes back with a lot more requests after the first iteration's delivered. They want more file types. They want OCR support. They also want a timeout for long-running jobs. They want bounding boxes in the cases where it applies. And suddenly the number of arguments going into that function has grown significantly. So Sam updates the client, and he finds it a bit too hard to use, just as he expected. The arguments are hard to read. Documentation is not great, because it's decoupled from the arguments. You can't really reuse the arguments. And on top of all of that, his old tests broke because the new arguments have changed the sequence of positional arguments. And since you can't really force everyone to use keyword arguments, then it's not really backwards compatible. And validation absolutely sucks. So he tried implementing some validation code, and you can see that you have to write a lot of boilerplate logic in the beginning of your function. And so Sam thinks to himself, there must be a better way. He thinks about it for a while and remembers a pattern he's seen in several languages, mainly used to configure things. And that would be configuration classes. We just need a constructor that can also run validation on each one of the arguments. After implementing it, we can see the upsides and downsides. Documentation is still not great since it doesn't have good autocomplete support, but the arguments are laid out in a way friendlier way for developers at least. Validation is also still not perfect because it still has to happen in the beginning of the constructor all in one place, but it's still an improvement. And now that we're using data classes, we can also force the use of keyword-only arguments, which would make the configuration class backwards compatible in case Sam updates it in the future. But there are still some downsides, and Sam thinks about how he could improve these. He'd still like documentation to happen on a per parameter basis, and same thing for the validation. And this way the documentation would also show up in the autocomplete, for example. Enter functional options. Here you can see a normal Python function with normal arguments, and you can also see a functional options version from Go. You can notice that the arguments are now function calls. And to make things even weirder, the function calls themselves return functions. You don't have to worry about the implementation for now, though. It's just about exploring this solution and seeing where we end up. And by turning these function arguments into function calls, we can now get a detailed documentation, which is basically a docstring per each one of these functions. On top of that, each one of these function arguments can take arguments of their own, which opens up a whole new world of possibilities involving what we can do with them. And here you can see an example usage of this. We initialize the getTextOptions builder, and then we can use it to spawn the function calls. In this case, it's just a container for these static methods. So what are the advantages of this? Here you can see the first advantage, which is how validation now works. Validation is now specific to the argument, which is this function with timeout. And we can easily validate that the timeout is a positive integer. We can also have a docstring in this function, which would also improve things for autocomplete. So ignore the part where we're returning a function here. So the with timeout getting returned, that's just an implementation detail. If you look at the implementation in the end on your own, in a few minutes you'll understand it perfectly. For now, let's focus on the advantages and disadvantages at a high level to see whether or not the solution even makes sense. So, validation is better. This is neater than bunching up all the validation logic in one place. We can now do this per argument. What else is there? Documentation looks a lot nicer, because now that each function is separated, now that each argument has a function call of its own, we can use separate docstrings. And we can also select our arguments via autocomplete. So, how would this look like? Sometimes we need more documentation. This is why having the docstring here makes a lot of sense and improves things a lot. You can see, for example, here the inline OCR argument. Changing this might have big effects on your application, even though it's a simple argument. And explaining these effects and communicating them properly is not easy, because you need to say quite a few words. So imagine this was just one argument in a massive docstring in the traditional function. So this is a lot nicer. You can also see that we can have multiple arguments inside each one of these function calls, and then this opens up a whole new world of possibilities in terms of what we can do with these functions. So for example here, the with dual arguments argument itself can take in two arguments, A and B. Then we can do validation, and we can return a different combination of these arguments. So this basically can help a lot, because the alternative without the functional argument version is to take two arguments A and B, and then if one exists, validate that we also have the other, and only then can we combine them and return them, because you can't really mandate that both optional arguments exist, because they are optional by nature. So this basically allows us to do things that we normally can't. So Sam was really happy with the end result, and while discussing these functional options with a friend, his friend mentions that this looks a lot like a builder and chain implementation, at least in terms of usage. And that pattern is already well established and widely used. So he was curious as to how they compare, and why a builder and chain was not enough in Golang. So Sam implements this builder and chain, and it looks even better. It still meets all the criteria he was looking for before, in terms of documentation, validation, autocomplete support, etc. So then what's the difference between these two? They look so similar. Builder and chain looks a bit simpler, while still achieving the goals. Comparing both usages, even the usage is simpler, not just the implementation. But there is one tiny difference. Can you spot it? It's very hard to notice, because it only affects things after you call these functions. The builder and chain methods are executed on call, while the functional option builder only returns callables, which means that they won't be called until they're really needed. A kind of lazy evaluation, as you will. So generally speaking, I would say that functional options don't really have a place in Python, unless you're really looking for that edge case where you want lazy evaluation of these options. I think builder and chain is more than enough to satisfy most needs. Now that we're here, why can't we just use a builder and chain in Golang? So Sam is finally satisfied with this solution, and we can finally move on to looking at the Golang implementation. So I'm not going to talk too much about this, because John Calhoun already talks about this in a blog post in quite some detail. So I'm not going to spend time diving into that rabbit hole, since it's Golang specific. But I'll give you a spoiler, something you might not have known about Golang. In Golang, methods can't just throw exceptions. You have to return them, and then process them at a higher level. And this is very different from dynamic languages like Python and Java, where you can just raise an exception anywhere and accept it anywhere else near the top of the stack. So you can see in this implementation that it's a bit awkward to handle all these errors, and you can't really chain methods as you would normally. You could do some things to make it work, but it's not going to be pretty. And this is basically why. In conclusion, if you have a lot of arguments, use a builder and chain. And interesting solutions from other domains might apply to yours. And this is how I discovered why functional options don't work here, and why a builder and chain is even better for wrapping clients. And that's it. Thank you for watching, and I hope you enjoyed the talk.